Today we will continue with the same chapter, heat transfer. Previous class I taught you about the expansion, type of expansions. There are three types of expansion I told you. Linear expansion, superficial expansion and cubical expansion. Linear means lengthwise expansion. Superficial is area-wise expansion, means length and breadth both are expanding. And cubical means volume expansion. Which state of the matter expands the most? We say gases. Which expands the least? The answer is solids. What are the evidences of linear expansion? When we heat any rod, maybe iron rod you heat, then you will find that the initial length and the final length will be different. Initial length is suppose 1 meter, then final length may come 1.2 meter, 1.1 meter as on heating it. So expansion will come to know. What is the evidence of superficial expansion? Superficial expansion's example is linear expansion. Example can be other cases also, like suppose we are having railway tracks like this. Railway tracks. Between two tracks there is a small gap left. Why a gap is left between the rails? This is a kind of reason type question. The reason is during summer time length expansion takes place. Length of the track will increase. This will also increase, both the sides. This side also will increase, this side also will increase. So the gap is left to accommodate or to allow the linear expansion. If we don't leave a gap, then expansion may cause the breakage of the track. I mean the uneven surface to be formed between the tracks. Because the tracks, we cannot make single track all over, so we have to use the tracks in terms of parts. But the two parts we do not put in contact and join them together. We don't do that. We always leave a gap between them. Because the gap, the space left between the rails, this gap will accommodate or will be allowing the linear expansion, will be adjusting the linear expansion within this gap. If the gap is not left, then one will be hitting the other, the track will become crooked, uneven, and there is a chance of accident in that case. Now another situation is that this is the case of linear expansion. We say during summer time the duration of the day is longer. What is the reason? The pendulum of a clock will move slower, that means the duration becomes longer. The reason is during summer time linear expansion takes place. I am talking about the clock, wall clock, where there is a pendulum. The length of the pendulum will be increasing there. When the length of the pendulum increases, then the time period will also increase. And that's why it will move slower. It will take more time to complete one oscillation. It will move slower and the duration of the day is longer. Now we have another reason type questions, or you can the case of linear expansion or linear contraction. Between the poles, the wires or the cables are kept loose. Between the maybe electrical poles, we have got two electrical poles. Between the poles, the wires are there, but the wires are kept loose. What is the reason behind why we keep it loose? The reason is, suppose if you keep it tight, think about the winter time, cold weather. During winter time, due to cooling, the contraction will take place. When we heat, expansion takes place, but when we cool, contraction takes place. If contraction will take place, what will happen? This wire or the cable will snap or will break. But when you keep it loose, it will accommodate or it will allow linear contraction. Contraction will take place since it is already extra length, so it won't break. It is not tight, it is loose, so at the most it may become slightly tight, but it will not break. So it will prevent the breaking or the snapping of the cable. That's why we keep it loose. Then the other case of linear expansion is bridges are kept on rollers. Whenever we have bridge or bridges, both the ends of the bridges are kept on the rollers. There is ball bearings and there are rollers over there, and there is a gap between them. Because during summer time mainly the expansion takes place, that roller will make the length of the bridge longer. Both the sides, this side also will increase, and the gap will be accommodating the expansion. That is the reason behind. So these are all the cases of linear expansion. You have recent test questions may come in the exams on the basis of this. Even when we join pipes, one pipe, another pipe, and water pipe I'm talking about. The one pipe and another pipes are joined together by a socket. But the socket will keep a gap between the two pipes. The two pipes will not be joined end to end, directly like this. There will be a small gap between them, and the gap will accommodate the linear expansion. So that is the idea. We got so many cases we can think and answer on the basis of this. Now, I will be discussing the case of area expansion or superficial expansion. In mainly the cart wheel is used in the horse cart or the bullock cart. The wheel will be made up of wood. Wooden wheel is there. And the wooden wheel, when it moves over wet surface or muddy surface, there is a chance that the wood will get spoiled. How do we increase the life of the wheel? We increase the life of the wheel by putting a ring over it, by putting an iron ring or steel ring over it. And what is the idea behind? The idea behind is the ring which is to be fitted over it will be taken slightly smaller than the size of the wheel. Will be taken slightly smaller than the size of the wheel before it is being fitted, when it is cool. Now we will be hitting it. This is the iron ring, this is wheel, this is iron ring. Iron means this the cover of iron ring over it. Now we will be heating it. When you heat it, when you supply heat, this is heat, sign for heat, the side of this will increase. Area expansion will take place, superficial expansion will take place. Now the side of this will become bigger. So now that when it is hot, then we will be keeping it, this side will be slightly bigger than that. So that will be coming over it like this. This iron ring will come over it after heating. Now we allow it to cool. When you allow it to cool, what will happen? It will be contracting. When it is contracting, it will be exactly fitting over the wheel itself, tightly. It will have a tight grip over the wheel. So that is the idea. How do we fit an iron ring over a wheel? You may have a result test questions maybe coming on this. In wooden wheel or in the wheel of horse cart, the iron ring which is to be fitted over it is taken small. It will be taken in smaller in diameter before it is being fitted. Okay, this is the case of superficial expansion. Now let us take the case of volume expansion, mainly liquid expansion and the gas expansion. You must have seen, it will take some liquid in a flask like this. This is called measuring flask. Measuring flask like this. You may take some liquid, or let us take water here in it. So now once you heat it, you will find once you supply heat, you will find that the level of liquid, that is water, is increasing. It is coming here. So this is a case of cubical expansion. Volume is expanding in the liquid, and the margin of expansion depends upon the nature of the liquid. Different liquid has different ability of expansion. Some expands more, some expands less. For example, let us take the case of water and alcohol. You supply the same quantity of heat, or you raise the temperature by the same amount in both, you will find that alcohol expands more than water. If you take the case of mercury and water, then mercury will expand less as compared to water. At home, normally we see every day we boil milk and we boil water also in order to make tea and in order to cook something. We boil water. You must have observed that the expansion in water after heating, it will also increase, the level will increase, and milk's level also increases. But the expansion in case of milk is more than plain water. So it depends, expansion depends upon the nature of the liquid, what kind of liquid we are having. Now how to demonstrate or how to show that the gas also expands? Gas normally we don't see. There are many gases which are colorless, we don't see, but how do we know that it expands? How can we prove? By experiment. We can do a simple experiment on it. We'll take a empty container. Let us take a container, any type of container you can take. I'll take a container like this, empty. That means this is filled with air. Nothing is there, that is filled with air. Now, on top of it, we'll be putting a balloon like this. This is a balloon. There is a balloon on top of it. Let us heat it now. Once you heat, once you supply heat, you will find balloon now will be inflating. The balloon will become like this. The balloon will inflate. Balloon will be swelling up now like this. Will be inflating. You know the reason why? Because when we heat it, air is present, the air expands. Volume of the air is increasing and is going inside the balloon, and balloon is getting inflated due to the expanded air inside it. So these are the evidences that the gas also expands, and the gas expands the most. So you may have results and question whatever I discussed on it. Okay. Now the remaining part of this chapter is boiling and evaporations. In the previous chapter, I think chapter number 2, we had chapter number 1 we had discussed about that, the differences between evaporation and boiling. Here you have to learn the same thing, same differences. But once again a revision of that. What is boiling? We say it is a process in which a liquid changes into gas or vapor at a fixed temperature. What is evaporation? It is a process in which a liquid changes into gas or vapor at all temperatures. At all temperatures. That is the main difference. But what is the similarity between them? Both are the process in which liquid changes into gas or vapor. That is one. And what can be the second similarity between them? I am talking about the similarity. In both the process, the liquid changes into gas or vapor. That is one similarity. What is the second point of similarity between the evaporation and boiling? The second similarity will be that evaporations and in the boiling there will be loss in the mass of the liquid. In both the process, mass of the liquid, which is either getting boiled or getting evaporated, decreases. And it is a matter of common observation, you know that about that water molecules will be going out in the form of vapor. So definitely the quantity of the water molecule, if we are heating water or water is getting boiled or water is getting evaporated, will decrease. Let us take some petrol in our palm. After some time you will find that the petrol gets finished. You know why? Because evaporation is taking place. All the molecules of petrol gets evaporated and then there is nothing left. So mass is decreasing. In both the processes there will be decrease in the mass of the liquid. That is the second point of similarity. And what are the points of differences? I think point of differences you have done last time also. You have made a column. Same thing we'll do. Evaporations and here boiling. What is the first difference? It is a slow process. Evaporation takes place slowly and steadily, and it is a fast process or it is a rapid process. That is the point number one. You can check, you can compare with the previous chapter whether you have written the same difference. If not, then you can add on some new points. Second point of difference is it takes place, it occurs at all temperatures, and it occurs at a fixed temperature, or at a particular temperature, fixed temperature. That is the second point of difference. Third point of difference is evaporation causes cooling effect, and boiling time it does not produce any cooling effect. Whenever there is evaporation, it brings cooling effect because the molecules from the surface gets evaporated. So the molecules which is below the surface will be colder. So it brings a cooling effect, it does not bring any cooling effect. Number 4, it takes place only from the surface of the liquid. So it is a surface phenomenon, or it takes place only from the surface of the liquid, whereas boiling takes place throughout the entire mass of the liquid, These are the point of differences. And in that chapter only I discussed already about the rate of evaporation and the speed of evaporation depends on what factors. If you remember, it depends upon the surface area or area of the liquid surface exposed. On area of the surface exposed, it depends on that first factor. Means directly goes when the area of surface area is more, then evaporation rate will be also more. It will evaporate faster. It depends upon the temperature of the liquid surface. More the temperature, more the evaporation takes place. It depends upon the nature of the liquid. Some liquids by nature evaporates more, some evaporates less. It depends upon the nature of the liquid also. It depends upon the wind or the air blown over the liquid surface. When the air or the wind blowing over the liquid surface is more, and the speed of the wind or the speed of the air is more, the evaporation will be faster. and rate of evaporation is affected even by the presence of moisture or humidity in air. More the humidity, more the moisture, less will be the rate of evaporation. In cloudy weather, it is difficult to dry clothes because the rate of evaporation is less. The recent type questions you may have, so we already discussed in the previous chapter, so it is all the same. So this much only you have to learn from the chapter heat transfer. This is a short chapter, so you need only 2 class 1 I already gave, and this is the second one. So this much questions only you are supposed to know according to the reduced ICC class 8 syllabus. So next class we will be doing about the sound, or the rather sound energy, the next chapter. That also is a short chapter, it won't take much time, maybe at the most 2 classes it will be over. So thank you very much.